Sandra, and I'll be talking about Newton's first law.
And I'll be talking about Newton's second law.
My name is Octavio, and I'll be doing Newton's third law. And we are the Newton Group.
Newton's first law of motion simply states that an object in motion tends to stay in motion and an object at rest tends to stay at rest unless acted upon an unbalanced force. What's an unbalanced force? Well, I've got this golf ball right here, and I can apply force on it, but it's not going to move. It's still steady because this is a balanced force. The force that I'm applying on the golf ball is equal by the force in my hand pushing it up. But if I move the ball this way, it should move.
States that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. To find acceleration, you must divide the net force by the mass or multiply the mass times the acceleration to find the net force. When I push Octavio, I would need less force. I would want to push the vending machine, I would need more force. An object that has more mass would need more force, but if the object has less mass, it would need less force.
What happened there is that I, Octavio, pushed Joey. And he fell. The thing is, at the same time that I pushed him, the force was returned to me in an equal and opposite direction. This means I was actually pushed back while he was pushed forward. Another example of this would be a rocket. Do not judge my drawing skills. Or firework. Both of them work. While the fire is pushing this way, the rocket is going this way. That is a simplified version of Newton's third law. Another example of this in a human form is if there is a wall and someone is leaning against it. Do not judge again. A certain amount of force is being exerted on the wall, but at the same time the wall is pushing back. Or in Muhammad Ali's words, the punching bag fights back.